Let's now continue on with our Chapter 1 Introduction to Python material with the Section 1.3 on functions. As we saw earlier, to create a function in Python, you need to use the def keyword to define the particular function you want to follow the def with a particular name, and then using parentheses specify all the parameters necessary, close the parameter list with parentheses, and then do not forget the colon. The colon then starts the code block associated with that function, keeping in mind, again, scope is determined by spacing, so you must space over the same number of spaces and start all your statements of your function, including a return, and then return the particular value or values that you want. What's interesting in Python is that you can return any number of output parameters that you want. Makes it very, very flexible, so functions can be more general than perhaps in other languages. Now, below we have an illustration of a particular kind of function that will be commonly used in scientific computing. In other words, finite differences, and the particular function we've created below is called finite_diff. Now, we will see a little bit later that if we need to use other functions that are provided in other libraries, you can do that very easily by using from a particular library and import any particular function name that you need. So the line you see here actually does what I just said. Using the math library, if we needed to get access to the arctangent or the inverse tangent function, here's one way of doing that. Now, you also can use a wildcard notation rather than saying arctan if we simply had an asterisk here and said from math import star. That would import all the functions from the math library. But for efficiency purposes, you probably don't need to do that, and you probably just need to import exactly what you're using. One advantage of that is it helps other people when they read your program or looking at making changes to your program, they can see specifically ahead of time what functions you're importing. So even though import star is easy, for other people working with your code, it might be nice to sort of list with the specific functions that you're using. All right. So we'll see how arctan is used in the next slide. But right now, we're defining a finite difference function called finite_diff, and then begins the parameter list. F is going to actually be a name holder for the function that we're going to use in the finite difference approximation. And then the independent variable will be x, and then we have a step size or a parameter called h. And notice that you can initialize that parameter within the definition of the function very easily. So that's a very nice feature also, that you can initialize it, in this case to 0.0001. Again, close the parameter list with the parentheses, and then with a colon, start the definition of the function. Again, you must space over. You cannot stay in the same column with that first D on the def. You must space over. It's up to you to decide how many spaces. Don't use tabs. Tabs are not conformable across all possible machines with the interpreter, so they try to avoid using tabs. So in this case, we defined one particular difference, df, as the function evaluated x plus h minus the function evaluated x minus h, and we divide that by 2 times h. That's literally like a formula that we use in divided differences, and we will see that later on when we're approximating derivatives. And then ddf is sort of a representation of a second derivative, and it's a different way of using the function. You would need to evaluate it at x plus h minus 2 times f at the function f at the value x, and then you must add f of x minus h, and that entire numerator is divided by h squared. Again, those are two standard formulas easily written in Python. All it's required is knowing what h is, knowing what x is, and then what the function f is. And that's actually passed by name here and then evaluated as a function call. So you can return both of those quantities for the finite difference function. So you would probably want to put some comments to tell the person when you call this, you're going to get two things back. Right? So if we actually look at an illustration of the usage of this function call, let's suppose we were evaluating the arctangent at 1/2, and we were actually approximating the derivative and the second derivative at 1/2 for arctan. So what's interesting here is noticing that we are passing arctan for f in that function, and then of course x, which is the value of the function the initial value of the function that we're using to approximate the derivatives. X is known also, it's 0.5 as we indicated there. But you'll notice that where's the third parameter? Where's the h? Well, remember h was, if you go back to the previous slide, if you'll remember, well, h was actually already defined. And so if it's already defaulted, then you actually don't have to provide it. It'll use the default value. Again, a very nice feature there. Now, if you provided an h, it would actually be overridden. The original default value would have been overridden. So if you said h equals 1/2, then it would have overridden the 0.001. And then, of course, you can you can print out the first and second derivative values using those print statements right there. Now, one question that comes up frequently is what happens to a mutable object if it's passed to a function? And the classic example would be a list. Remember, not a string, but a list would be mutable. So here's a very simple function calling squares, and it takes a parameter a. In this case, we're assuming that a is a list. Again, that probably would be good to put in a comment that we're assuming the input is a list. Then using the range function over the length of that list, so that I would be the index that would run through the range of length of a. Remember, the length of a will return how many elements are in the list, and then range is going to produce the indices 0 up through that number of items minus 1. And in this case, what we're doing is we are updating each element of the list with its square. So illustrated below, if you had a list of 4 elements and each element was an integer and they were 1, 2, 3, 4, and then here's an illustration of printing out what you would get if you called squares of A. So immediately it's important to realize that, well, the length of A in this case, the length of A would return 4. And of course, what the range is going to return when you execute this for loop, it's going to return the list 0, 1, 2, and 3. Again, because if you don't provide a starting index for the range, it will assume it's always 0. Okay. So what happens here is that that function is attempting to change all the elements in your list, and by George it does that, because what I've indicated down here at the bottom is the output that you're going to get. In other words, it will square each of those elements. The list has mutable object, is a mutable object, so all its elements can be changed. And so this again can be very helpful, that you can save storage by providing a list and then automatically updating all the elements as needed. A really nice feature related to functions in Python are what are called Lambda functions. This may be something you're not familiar with, depending upon the other language that you use, but there are languages that provide this capability. And basically the way to look at Lambda functions, which actually evolved from the concept of lambda calculus in the theory of computing, is that you can take an expression and actually create a function using it. This can also almost be done, you can think of this almost being done dynamically as the program executes. But it enables a list of actions to be done, which is Very, very, very nice. Here's just a very, very simple illustration. We won't need lambda functions right now for the most part, but it's just something to think about. You might find it useful to look it up in other reference material related to Python. But here's an example of creating a function called C. And to create a function called C, you would use the lambda keyword, as indicated here. And after indicating that it is going to be a lambda function, you would provide what are the parameters for it. So it's going to be the two-parameter function xy, colon then initiates the expression that's going to be used to create the function, and then what follows here is, as you can see there, is we're creating a function that takes the sum of two squares, x squared plus y squared. So what's really cool is you could imagine a particular point of executing a particular code that would generate an expression here. You could have different kinds of formulas that are being generated on the fly by your program, and Python will automatically create functions for you, so that you could almost imagine, you could have tables of functions very easily and lists of functions very easily, because every object of the list could be a different expression, and then you could just execute that element of the list. And so here's the syntax for actually executing this lambda function, is just indicating its name followed by the parameters 3 and 4, and the output, of course, is indicated here in blue, would be 25. So again, a very advanced kind of feature of functions in Python, but I think you'll find that very, very useful. And as mentioned earlier, in terms of how to use functions that have been provided in other modules or libraries in Python, and there are many, the syntax is very clear. You need to use the from keyword and the import keyword. And as I mentioned before, you can always import all the functions that are available out of a module by just using the asterisk. So that syntax from the name of the module import star would get everything. Another way, of course, is you can, if you wanted to, you could just use import math, and that would get all the functions as well. Again, it's kind of good to use the from import and have a specific name. Like we had earlier, you could maybe have arcsine or something like that. So just specify the function that you need, and therefore it gives sort of a foreshadowing to someone using your code what functions you're going to be using, because import star won't tell you anything until someone finds it farther down into your code. The interpreter, you can see what's available in the math or any module by executing this particular function called dirf or directory, and you would see all the names of the functions that are available. For example, a specific modules you need for certain kinds of functions. If you wanted to manipulate complex numbers and use functions specifically for complex numbers, you need to import CMath. And again, we indicated this very early at the very beginning of the course, that NumPy or NumPy, depending on how you say it, is needed for most of the functions in the rest of this course. So this is a module that you're going to have access to. So when you've installed Python, you need to make sure that you install the NumPy library module as well.